Hi students, today I am going to explain to you about the concurrency problems in transaction management. Okay, so I had posted a video on the basic concepts in transaction. Hope all of you have viewed that lecture. Okay, but here I'll be giving you a brief intro on that once again. So in the previous lecture there I have discussed about what a transaction is and the basic concepts related to transactions. So basically, what do you mean by a transaction? So that transaction, it was a group of tasks, okay? A group of tasks which did an operation as a logical unit. So it had the properties like atomicity, consistency, isolation, and durability. That was the main properties of transaction, which we call as the acid properties. So we had discussed about that also, what acid properties are. Then we discussed about the state transition of a transaction and the main statements like the commit statement and the rollback statements. Okay. So these were the main things we discussed in our previous lecture. So transaction, it is basically a group of simple tasks joined together to perform a common scenario task. Okay. So these simple tasks will be the read and write operations. So a combination of these read and write operations performed together to achieve something or to perform a main task. Okay. That is what is called a transaction. So there we have discussed another thing about schedule. So if there are more than one transactions occurring at a time, okay, so it can be performed in two ways. Either it can be executed sequentially, like in a serial manner, one transaction, when it completes its execution, then we can begin with the other transaction. That is what we called as serial schedule. And there was another thing known as non-serial schedule. In this, there was an interleaving of operations. Okay, so that was called as the non-serial schedule. And there we had discussed that this non-serial schedule, though it gives an increased throughput, there will be concurrency problems. Okay. So that concurrency problem is what we are going to discuss in this session. Okay. So now we'll go into our topic. First, what is database concurrency? Actually, this database, the main advantage of database, its ability to allow multiple users to affect multiple transactions. Okay, that is the main advantage, or that is why we prefer this database structure. So if this concurrency, so it cannot be avoided as such, because without concurrency, this multiple access will never be possible. So we have to deal with it, but this concurrency gives problems too. Okay? We can think of this multiple access like, for example, an online exam, in that all the students will be accessing the same question, and they are able to read the same data at the same time. So if it is a data, just a reading operation, this concurrency is not going to create any issue. But this concurrency will create issues only in certain scenarios where a combination of read and write operation come in a particular manner. Only then this concurrency becomes an issue, and this concurrency is not always an issue. Okay, so just remember that concurrency, this interleaving always leads to concurrency, but this concurrency becomes issue only when that interleaving is in a particular fashion. Okay, so that interleaving way is what affects the or which leads to the problem. So in this slide we'll be discussing which all scenarios this concurrency will lead to some problems. Okay, so we'll just go through these problems one by one. First of all, just I'll be giving a recap on that non-serial execution, okay, or the concurrent execution of a transaction. Okay, here just see there are two transactions T1 and T2. We have discussed this already. And here, after performing the two operations in T1, then we are shifting to transaction T2. So concurrent execution doesn't mean at a time we are performing both the transactions. Just keep that in mind. At a time we never do two transactions together. It's just an interleaving, but it takes place so fast that for a user it feels that T1 and T2 is executing parallel. That is what we mean by this concurrent execution. Not that at a moment we are doing things parallel. Okay. So this is a structure of a concurrent executed transaction combination. Okay. T1 and T2 working in a concurrent fashion. So this type of execution, now we'll be seeing in which all scenarios this concurrent execution will lead to problems, what the problems are. Okay. So we'll see that in the coming slides. These are the main concurrency problems. It is temporary update problem, incorrect summary problem, lost update problem, unrepeatable read problem, and phantom read problem. Okay. So this is a very important topic. So just go through these topics very well. First is the temporary update problem, or you can call it as a dirty read problem. So in this, see there are two transactions T1 and T2. And first the T1 transaction is being executed. It's reading an item X and it is updating its value. X is decremented by a value N and it is then writing that value X to the database. But this write item X without the commit statement means that this transaction can be undone, okay, at any time. It can be aborted at any time. Until the commit statement is executed, no transaction is permanently saved in the database. So this write item X, though this statement changes the value of X, it is never final. Okay. After this write item X is executed, then T2 is reading this updated value. Okay. So now T2 gets the updated value, that is after the decrement. Okay, and then this T2 is incrementing that value by N and it is again updated. And here now just think that this transaction T1 is facing some errors or some system problems and this T1 is forced to abort its transaction. Means it is not able to complete its transaction. So it is going to roll back this transaction. Okay, and it will be undoing what it has done. So this when it is rollbacking, this X value is reverted to its old value. Okay, and that time, then what T2 has taken, it becomes a wrong value because now T1 has changed back to its old value and T2 is having a dirty data with it. Okay, so a wrong data with it. That is why it is called as dirty read. Now T2 no longer has a valid data with it. So this read operation becomes a dirty read operation. So this is one problem we face because of concurrency. Okay, this is a scenario in which it is caused. First, a transaction is executing means a write operation, and then the other transaction is reading that updated data. Then the first transaction is doing a rollback. Okay, due to some failures. In that scenario only, this problem appears. Okay, now we'll go to the next one. So next is the incorrect summary problem. This incorrect summary problem takes place when we are applying aggregate functions. Okay, like this sum, average, all that. When you are performing such aggregate functions, if a transaction is performing such aggregate functions only, these problems can arise. So in this case, see, there are two transactions T1 and T2, and T2 is doing a sum operation. Sum is equal to 0. It is reading a data item A. It is adding it to the sum. Okay. After that, transaction T1 is reading a data item X. It is updating its value and it is writing it. But it's not finalized. It is writing its value. Then T2, what it is doing is, it is reading this item from this updated item. Okay, T2 is reading the updated item X. It is adding that updated item to the sum, which is already having A. If X is added to that sum, then it is reading item Y. So item Y is still not updated, but this T2 transaction which is reading item Y and it's adding that item Y to the sum. So now our final sum contains A, the updated X value and the Y value which is still not updated. Okay. And after this operation, now T1 is updating the value of Y. T1 is reading item Y, it is incrementing its value and it's updating. So here now, after this, when we get the final answer, the sum value will be wrong value because by the time it displays the sum or it writes the sum value, this Y value has changed already. Okay. So the final result we get in the aggregate function, it is a incorrect value. That is why it is called incorrect summary problem. So this incorrect summary problem happens in situations where we are doing aggregate functions. When either of the two transactions is doing an aggregate function while the other transaction is updating those data items at the wrong time. Okay. So if this operation was shifted to this place, that is if read item x, x is equal to x minus n, write item x, then this read item y, y is equal to y plus n, write item y, all this was performed together and then if we were doing this operation, there wouldn't have been this problem. So only the order in which these operations are taking place leads to some concurrency problems. If this order is changed, then that problem can be avoided. Okay, so these problems purely depends on the order in which these transactions are executing in a concurrent or non-serial schedule. Okay. Next one is a lost update problem. This lost update problem, it happens in scenarios where two transactions are subsequently updating a data item. So here just see transaction T1, it is reading an item X and X is equal to X plus N. It is updating its value by N. Okay. But it has not written that item still. This right item X is still not executed by T1. So it is not saved to the database. And here T2 is not reading the item X. Okay. T2 is having the old X value which T1 also has read. So T1 and T2 has read the same X value now. And X is equal to X plus 10. So T2 is updating it by a value of 10 and it is writing that item. So the updation which is done by the later transaction only will be saved. So this updation is getting lost. So this lost update problem happens when T1 or when two transactions are going to update the same data item sequentially. Okay. So only the updation of the later transaction gets saved and the other gets lost. That is the lost update problem. Next is the unrepeatable read problem. Okay. This unrepeatable read problem occurs in cases where a transaction is performing continuous read operations on a data item. Okay. So just see the scenario. There are two transactions T1 and T2 and T1 is reading a value X. T2 is also then reading that same value X. And next case T1 is updating this data. It has performed some operation and it is updating this value X. Now T2 is again reading that value X. So this time when it performs the read operation, it gets a different value because of this write operation. Okay. Because of this write operation, in the subsequent read, this T2 gets a different value. So this T2 is not getting the same value during the repeat operations. That is why it's known as unrepeatable read problem. In this case also, if this write X was here, this problem wouldn't happen. Okay. So in all the scenarios, it is only a just shifting of an operation which leads to this problems. So here, if write X was here, both these read operations would have got the new updated value. In this scenario, one is getting the value which is not updated and the other is getting the value which is updated. So they are not able to understand which is the right value. So this is known as the unrepeatable read problem. Next is the phantom read problem. In this also, same like the unrepeatable read problem, one transaction will be trying to read the same data value simultaneously, repeatedly, and see first in first case T1 is reading a value x, T2 is also reading the value x. After that T1 is deleting that value. Okay. That variable x is being deleted by transaction T1. Then again T2 is trying to read that value x, but this time it gets an error because this data item x or this variable x doesn't exist anymore. So when it is trying to repeat the same operation again, it leads to an error. So this is known as phantom read problem, where a deletion takes place between the subsequent read operations by a different transaction. Okay. So here T2 is doing the continuous read operation, while T1 is doing the delete operation between these read operations. So this is known as the phantom read problem. These are the main concurrency problems which can happen due to the concurrent execution of transaction. And to prevent these, we have some concurrency control techniques which we'll be covering in the next session. Okay. So hope you understood this topic. Thank you.